A tutorial by LearnFast Studios.
Inter-thread communication. In inter-thread communication, we mainly use threads. A thread is an independent flow of execution. We can use threads in two ways, by extending threads class or by implementing runnable interface. Let us see a program about inter-thread communication. Take a class inter-thread communication example and main method, and let us write a program which is a communication between a producer and a consumer. So here we take another three classes, one for producer and another for consumer and another for the linked buffer between the two producer and the consumer. So let us write that buffer place. Let us make it as class Q. So wait. In this class, let us take a variable in which the producer puts the some value and consumer takes that value. Let us take C in C and now take a boolean value which will use it to make any one of the thread or one of the process to enter into it, mainly thread. In inter-thread communication, we mainly use two methods, notify and wait. Let us see them. Notify and wait methods are only used in synchronized methods. So we need to take synchronized methods in producing the object and consuming the object. So let us know what is a synchronized method. Any method declared as a synchronized method will only allow only one thread to enter its code. Whereas synchronized block means when a particular region of the code should be synchronized, then it must be kept in a synchronized block. Synchronized method means only one thread can enter that method. Synchronized block means only one thread can enter that particular block of statements in a particular method. So, wait method is called when the remaining threads entering into that method making into waiting state. It makes the remaining threads enter into the waiting state. Once thread has completed his job in its critical section, then it calls notify method, which makes the waiting thread enter into its another waiting state. Now when lock is given, the thread enters into the runnable state. This wait and notify methods are in object class. Let us implement this wait and notify methods in synchronized method. So here when notify method is called, it requires a lock to get from another waiting state to the runnable state. For that lock, we are using a boolean value flag which is initialized to false. Now let us write a synchronized method to put the value into the C, which is a method performed by a producer. Let us write a put method. Synchronized void put, and I am passing an variable inside to keep that variable value in the C. So now let us verify whether the flag is false or whether it is true. First of all, the producer should enter this put method before the consumer enters into the get method. So first we will take if flag is true. Initially flag is false. That means initially producer should enter the put method. So flags should be false so that the producer can enter this put method. If the flag is true, then the consumer should not enter. So I am writing wait method here in the try catch block, because wait method will raises an interrupted exception. So I'm using try catch block to handle this interrupted exception raised by this wait method. So in wait method I'm in try block I am writing the wait method, and using catch block I will handle this exception. That means when initially the flag is false, so producer enter this put method, and flag is false, so while loop is false, so the remaining statements under the while loop will get executed. In the same time, the flag is true, that means the consumer will not enter this block, it will be in the waiting state. Now I am assigning this C value to our C value. This indicates the current class object. Now write a print statement that C is produced. Now call notify method. As the producer produced the value, we should change the flag to true. Now when flag is true, producer cannot enter this put method. As flag is true, it enters into this while loop, and we enter into the, it calls wait method, and it enters into a waiting state. Now to get the value, we will write an get method for the consumer. Public synchronized int get of int. I am using int here as return type because get what the consumer gets should be returned. Now again the same way we will use this wait method when the flag is false, when we use the wait method in this get. So when the flag is false, we call wait method. As it is raising an exception, we use try catch block. It is an interrupted exception, so I wrote catch of interrupted exception object. And now let us call notify method and make the flag as true, make the flag as false now. And finally we should return the C value. Now we completed writing put method and get method for consumer and producer correspondingly using synchronized method, because only one thread should enter these methods at a time. Now let us write producer class. This producer class is extending thread class, that is, now this producer class will get the all properties of thread. Now let us take an object for this thread class. I'm taking the object for this Q class and assigning to this Q class object to this producer object. Let us see this. Now I am assigning this Q object to the current class object. Now by accessing this Q, we can call this put method. As it is extending thread, we should override a method called run method, which is an abstract method present in thread. Now let us call the put method q.put. We have to pass the values here. Q.put of some integer values. So I am taking a for loop so that it continuously puts some values. So now q.put of I. And now let us write sleep method so that even though the producer puts the method and it is in sleeping state, so that the consumer will wait for the time completion, or in the meanwhile the consumer will get the C value. So we used sleep method. Sleep method rises an interrupted exception, so we need to write them in try catch block. As we are extending thread, we need not to write thread.sleep. We can simply write sleep of some value. That means here it waits for 100 milliseconds, and now catch block, catch of interrupted exception. Now our class producer is completed. Now let us write consumer class. This consumer class is also extending thread, so it acts as a thread. Now let us take object for the queue and assign it in the constructor with the current class queue object. Now let us call the get method by using this queue in the run method, which is to be overridden. In this run method, for the same for loop, that means it is keeping the values for 6 times. So here we are also have to use the same for loop to access the value 6 times. Now take a print statement to print that the consumer get that values, as it is returning some value. The get method is returning some value. Now same, let us write sleep method and use try catch block. Now our complete program is completed. We have to call this producer and consumer objects. First of all, let us create an object for the queue class so that we can pass that object to the producer and consumer classes. So call queue object and now pass this queue as parameter for producer and consumer. Using this producer P, we can access that put method. So P dot start we can call, because when we call this start method, the run method in that class will get executed. That is, when I call P dot start, these all statements will get executed. So P dot start, in the same way C dot start. Now both the threads run parallelly, and once it produces, the other will consume the value. Now let us execute. See, within seconds time gap, the producer is producing 0 and consumer is consuming 0. After that, 100 milliseconds gap will be there. In sequence, producer will produce 0 and consumer will consume 0 up to 5, as we took the for loop from 0 to 5. Let us see the state change of the thread in this inter-thread communication. When we call object for the producer and consumer classes, here I called object P for producer class and I called object C. That is, I created object for the producer class and created object for the consumer class. At this state, the both threads are in newborn state. When I call start method, the threads will enter into the runnable state. When I call the start method, thread will enter into the runnable state. In runnable state, if the thread scheduler allocates the processor for the thread, then they enter into the running state. At a time, only one thread will enter into this running state. When this in this running state, I am calling put and get methods. In them, I called a wait method so that the if in first situation here in runnable state I have consumer thread and producer thread. If thread scheduler allocated the processor for the consumer thread first, then it goes into running state, and in this running state it enters into this wait method. So it enters into the waiting state. As it is in waiting state, the thread scheduler will allocate the processor for the other thread, which is producer thread. Then it enters into the running state. When it finishes its run method, then it enters into the dead state. While entering into dead state, we are calling this notify method. So the consumer thread will enter into the another waiting state, and I changed the flag value so that it enters into the runnable state. Again, now when I'm in the for loop, I'm using this method many times. So again, the threads will be created and enters into running state. So this process continues. In this program, we learn about inter-thread communication by using synchronized methods and notify and wait method, and what is the need of synchronization.